Welcome to C Programming Tutorials. This is a production of YouTube channel Learnorama and the Facebook page Awesome C Programming Tutorials in High Def. If you haven't subscribed to the channel yet, I would recommend that you do so. Or if you and if you can become a fan of the Facebook page, that would be good too. So in today's tutorial, we are going to learn about dynamic memory allocation. Okay, we are basically going to see how you could actually at runtime, while your program is running, you actually allocate memory so that you do not use the memory, you do not use the stack for your variables. So let's get started. So we have learned that, so far what we have been doing is we have been creating variables on stack. We learned before, if you haven't watched that tutorial, you should watch that. We learned before that all the local variables that you create, all the variables inside the function that you create right at the beginning of the function, all of them are created in a very specific memory location or memory region, which is called stack. And the reason it is called stack is because it behaves like a stack. As the functions are being called, all the variables are created on the stack, and then that function calls another function, and then its variables are created on the stack, and then that function calls another function, so its variables are created on that stack. And when that function returns, the last function returns, it clears up all its variables from stack, and those variables don't exist anymore. So if we have int x, and then we have character c in the main function, and then there is another function, say void func of int y, and then bracket start, and then you have another variable called int a, and then another variable called char m, and then there is code here for this function, that uses a and m, and then, well, I should not do that, a equal to 0 and m equal to like c or something like that. I'm just writing any code here, and then this function actually calls func with some parameter x, passes x into this parameter y, and when this program starts executing, it starts from the main function, and these two variables x and c are actually created on stack. And then now let me see if I can draw this, and then so the stack looks like this, and when this main function starts, its variables x and the variable c, they are created right on the stack. And then when this function calls func, it actually goes in this function starts executing, and then its variables are created on stack right on top of this guy's variables, on main function's variable, and these are called stack frames. And then when this returns back and the control comes back here, what happens is these variables are removed from the stack. Okay, so the point is that those variables are created on stack, and as those variables are created, the stack is being used. So the problem is that if suppose I have a string which can have as many as 100 bytes. So if I define it like this, 100 characters, if I define it like this, what we are saying is that we are going to allocate this much space on stack, okay, which is going to be 100 bytes, because each character is 1 byte long, and this will end up in allocating 100 bytes, which is still not so bad. But what if you have a string which is like, I don't know, 10,000 characters long? If we have such a big string, it's like 10 kilobytes almost, 10,000 bytes, and this will create this will allocate memory space on stack, which will be 10,000 bytes long. The problem is that operating system allocates so much memory space for every program to be used for stack. And if you keep on doing that, if you have practice of doing this, if you in every function you have like large variables created inside the function, what could happen potentially is that as you call functions, you may overrun stack, and you may end up in storing values into somebody else's stack. So every program will have its own stacks, and if this is a whole space in the operating system for stacks, this could be the stack space for program 1, this could be stack space for program 2, this could be stack space for program 3. And if program 1, let's call it P1, if it has practice of creating big variables on stack, it might actually run into program 2's stack space. And while program 2 is going to be running, it will all of a sudden see that its values of its local variables are changing for no reason, and it will start crashing and all this. So weird bad things are going to happen in your machine if you do that. So what is the remedy for that? What do you do if you really have to have such a big string? You do this. You define a pointer, okay, to it, and always initialize pointer to null when you declare it. Okay, null is basically, or make it 0. Okay, that basically makes it point to like nowhere. All right, and then you use a function called malloc. It is memory allocation, malloc. Okay, and what it takes is the size of how many bytes you want to actually allocate. Okay, this is the syntax of this malloc operation. So how many bytes do we want? We want 10,000 bytes. So we use 10,000. Okay, and then it returns a pointer or the address of the memory location wherever it allocated this space, and it usually allocates it from heap. It's the operating system that does it for you, and it uses it from heap, which is totally different memory region from stack, and it returns back the address of this location. And where are we going to store that address? Inside this pointer pstr. Now after this, at this point, after executing this function call, what's going to happen is basically pstr will be pointing to a memory location somewhere on heap, which we have no idea where it is. Okay, and that memory location will have 10,000 bytes, and this pointer pstr will be pointing to here. And after this, at this point, you can use pstr as if it was a string declared like this. So what you could do is you could basically say you could say str copy to pstr, comma, and then whatever string you want to copy onto it, and this will store this string Sohail inside that memory location that you allocated for this string. So this is how you actually create large memories. You can have really big variables here created. Now suppose if you want to allocate an array of integers which have 10,000 elements. Okay, so you could do this int x of 10,000, right? But again, this will result in huge memory space, 10,000 integers. Okay, each integer could be 4 bytes long, so this will end up in allocating 40,000 bytes where? On stack, and we don't want that. So what do? You basically, instead of creating x as a pointer as the array itself, you create x as the pointer px, and then what you do is you'd say px is equal to malloc of 10,000, okay, times 4. Well, let me stop here and we'll continue it in the next tutorial because we are running out of time. Thank you so much.